Hello everyone. In this reaction, gas A and gas B react to form gas C. There is a cylinder and two containers, and initially two valves were closed. For the first reaction, valve 1 is open and the piston is fixed. So in this reaction, volume doesn't change. In second reaction, valve 2 is open and fix is removed, so volume may change after reaction is complete. And before the reaction, partial pressure of gas C is 5 times P, and partial pressure of gas B is X. After the first reaction, all of gas A is consumed, and the same amount of gas B and C is present. After the second reaction, partial pressure of gas C is 8 times P, and the total pressure after second reaction is 180, and total volume is 25 over 6 times V liter. So let's start with the gas C before the first reaction, because we know many things about gas C before the reaction. So using these three values in the gas equation, pressure is 5 times P, and volume is 2 times V, and the amount of mole is 2. And because temperature is constant, in this equation, RT is equal to 5 times PV. Let's think of the amount of gas A before the first reaction. Pressure of gas A is 0.5, and volume of gas A is V liter, and RT is 5 times PV. So the amount of gas A before the first reaction is 1 over 10 times P. And for the amount of gas B before the first reaction, pressure of gas B is X, and volume of gas B is 2V. So the amount of gas B before the reaction is 2x over 5p. And let's think of the total amount of gas after the first reaction. The pressure total pressure is 4/3 and the total volume is 3V. So that means the total amount of gas after the first reaction is 4/5P. And because all of gas A is consumed, the amount of gas C should be added 2 times the amount of gas A consumed, and that's equal to half of the total amount of gas after the first reaction, which is 2/5P. So if we solve this equation, 1 is equal to 1/5P minus 1/10P. So that's equal to 1/10P. So value of P is 1/10. That means the amount of gas A is 1 mole. And the amount of gas C after the reaction, half of this is 4. So 4 mole of gas A is present after the first reaction. So amount of gas B is also 4 mole because they have the same partial pressure. And originally amount of gas C was 2 mole, so that means 2 mole of gas A is newly formed. To do that, according to coefficient, 3 mole of gas B should be consumed. That means before the first reaction, the amount of gas B was 7 mole. So if this value is equal to 7, and P is 1/2, so the value of X is 7/4. And after the second reaction, let's think of the amount of gas C. So the pressure of gas C is 8 times P, and the volume is 25/6 times V. And C, RT is 5 times PV. So the amount of gas C after the second reaction is 20/3 mole. So that means from 4 to 20/3, additional (8/3 mole of gas C is newly made. And to do that, the formula of gas B should be all consumed because 2/3 of 4 is equal to 8 over 3. So now there is no gas B after the second reaction. And the partial pressure of gas C is 4 over 5 because P is 1/10. And to make the total pressure 1 atm, partial pressure of gas A is 1/5. And the ratio between the pressure is equal to the ratio in the molar ratio. So that means the amount of gas A is 1/4 of gas C. So gas A after the reaction is 5 over 3. 1/4 of 20 over 3 is 5 over 3. And then the amount of gas A consumed in the second reaction is half of gas C newly formed. That's 4 over 3. So before the second reaction, the amount of gas A in the second container is 3 mole. So finally, the product of A and X is, value of A is 3 and value of X is 7 over 4. So the product is 21 over 4. The right choice is the fourth one. That's it for this video, and thanks for watching.